Investigating the starburst Cigar Galaxy. The James Webb Space Telescope has been able to examine an area of intense star formation by looking through the dense gas and dust at the center of the Cigar Galaxy with its powerful and sensitive infrared vision. Messier 82 is another name for this starburst galaxy that creates stars around 10 times faster than the Milky Way galaxy. A significant portion of this starburst is centered in an area that NIRCam captured images of using both long-wave and short-wave infrared radiation. This demonstrated a hitherto undiscovered relationship between the structures of hot ionized gas and the sooty chemical compounds known as polycyclic aromatic hydrocarbons. As the quintessential starburst galaxy, M82 has attracted a wide range of observations over time, according to team leader and University of Maryland researcher Alberto Bolatto. The Hubble and Spitzer space telescopes have both studied this object. We can observe this star-forming galaxy and see all of this stunning new detail because to the size and resolution of the JWST. Solving the mystery of gas giant formation, disk winds, or the outflow of gas from a protoplanetary disk encircling a young star, have been studied by the James Webb Space Telescope. The observations may contribute to our understanding of the formation of gas giants such as Jupiter and Saturn. The study's researchers directed the JWST to Teachaw, a youthful, low-mass star around 350 light-years away from Earth. There's a known big gap in the protoplanetary disk that whirls around this star. Such gaps suggest that a young, developing planet is orbiting the star and accumulating material. The scientists could discover what circumstances favor the development of gas giants and rocky planets like Earth by examining how gas exits from this disk. The high-energy photons from the Sun will take away the atmosphere of rocky planets very near to the star, like Mercury, leaving very little or none at all. That's cool. I see ingredients for life swirl around infant stars. The James Webb Space Telescope has allowed astronomers to see a number of the constituents of stars, planets, and even life in ice form whirling around two young stars, or protostars. From very basic molecules to complex compounds, the complex organic molecules observed are diverse. A number of well-known substances have been observed in the vicinity of the protostars IRAS-2A and IRAS-23385. These include formic acid, which causes ant bites and bee stings to hurt, acetic acid, which is found in vinegar, and ethanol, which is what we name alcohol on Earth. The finding of the chemicals surrounding IRAS-2A is especially intriguing because these protostars would have been in their infancy 4.6 billion years ago, much like our Sun, before the planets formed. This suggests that the finding of these ice substances could support the theory that comet bombardments brought the essential components for life to Earth. Checking Hubble's work complicates expanding universe picture. After verifying the Hubble Space Telescope's estimates of the expanding universe twice, the James Webb Space Telescope discovered that its older sibling telescope was accurate. This may exacerbate a headache cosmologists already experience known as the Hubble tension. The Hubble tension results from the inconsistency between measurements of the universe's expansion rate using the cosmic microwave background, a cosmic fossil, and a method of measurement known as the cosmic distance ladder. One explanation for Hubble strain could be that the Hubble telescope's measurements, which were used to create the ladder's bottom step, were not precise. The rungs of this distance ladder are various methods for measuring progressively greater cosmic distances. The James Webb Telescope found that the bottom rung, which is measurements to Cepheid variables, or stars that pulse in brightness, isn't actually a bit loose after all. JWST observations with higher resolution showed that there is no apparent inaccuracy in Hubble's measurement of Cepheid variables. How do some bulk holes get so big? Researchers have discovered a population of supermassive black hole-powered quasars using the James Webb Space Telescope, which may provide insight into how these objects expanded to sizes comparable to millions or billions of times the solar mass. The little red spots of light that were identified as quasars are relatively small black holes that are in the transitional stage of becoming truly large supermassive black holes. This implies that this population of quasars may close a mass gap whose presence has baffled astronomers.